Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May-June 2023, Paper 2, Variant 1. And this is the second paper from May-June 2023 exam series. As always we will discuss these questions in detail so you can improve your conceptual understanding of AS Physics, and also you can have better understanding of these questions. And in today's lesson, our main focus will be on mechanics questions, means we will try to discuss first half of the paper. And in the second half of the paper, we will talk about waves, we will talk about electricity, and we will talk about radioactivity. Let's study together, let's improve together. In today's lesson, we are talking about May-June 2023, Paper 2, Variant 1. Total time for this exam is 1 hour and 15 minutes, and you need to answer all questions on this paper. And total mark for this paper is 60. On the second page of exam paper, some important data is given to you, means values of some important constants are given to you, and in the exam if you need value of any constant, you can come to the second page and you can find value of constant. And also on the same page you can see some basic and important formulae. In the exam, if you are in doubt, means you have doubt about any formula, or you have forgotten any formula from AS Physics, you can come to this page and also you can see some important formulae are given to you. But these are not all the formulae you need for your AS Physics. It's very important that you understand how to derive the formula, because when you derive the formula, you understand the physics behind that, and it's very helpful to understand physics. Question 1, part A says define power. Power is rate of doing work. Simply we can say work done per unit time. If same amount of work is done in shorter time, it means power is greater. If same amount of work is done in longer time, it means power is lower. So simply we can say power is work done per unit time. And this question has only 1 mark. If you write down this one, you will get 1 mark. Second part says use the definition of power to show that SI base units of power are kg meter square per cubic second. Very straightforward question. So we have to use definition of power, and power we have already discussed. This is equal to work done per unit time. So simply we can say this is work done over time. Work done over time. And work done is equal to Ft divided by time taken. And force we can write down F is equal to ma, and here we have d, and this is divided by time. And for mass we have SI base unit, that is kg, and for acceleration we have SI base units meter per second square, and for the displacement we have meter, and for the time SI base unit is second. Now we just need to simplify, so we can write down this is kg meter square and s to the power of -3. So this is how we can prove, and this question has only 1 mark. If you have derived this one, you will get 1 mark. Part B says the intensity I of a sound wave moving through a gas is given by this equation, where F is the frequency of the wave, A is the amplitude of the wave, and V is the speed of the wave. K is a constant that depends on the gas. For this question, we need to determine the SI base units of K. As we need to determine SI base units of K, so simply we can make K the subject of this equation. So we can write down K is equal to intensity over frequency square times amplitude square times V. So first of all, we can write down SI base units for each quantity. So this is a proper way of writing. So for frequency we have SI base unit, that is per second, and for amplitude we have SI base unit, that is meter, and for speed we have SI base unit, that is meters per second. And for intensity we need to understand this is equal to power over surface area. And for the power we have already derived SI base units, that is equal to kg meter square per cubic second, and for area is meter square. So from here we can cancel meter square with meter square, so simply we left with kgs per cubic second. So we left with kgs per cubic second. So we can say kg per cubic second. So this is SI base unit for intensity. Now simply we need to plug in these units. For intensity we have kg per cubic second, and for frequency we have per second, but its power is 2, so this is s to the power of minus 2. And for amplitude square we have meter square, and for the speed we have meters per second. Now we can further simplify this. We can write down this is kg per cubic second, and here we have s to the power of minus 3, and we have m to the power of 3 here. Now simply we can cancel s to the power of minus 3 and be left with kgs per cubic meter, or simply we can say this is kg per cubic meter. So this is the SI base unit for K. So we can say this is kgs per cubic meter, SI base unit for K. For second question, part A, we need to show that vertical component of the tension in the string is 2.4 Newton. So here we have the string, and we need to show that vertical component is equal to 2.4. So question is simply asking us the vertical component, means this component. This is the vertical component, and vertical component will be equal to 4.8 sine of 30 degrees. So simply we can say T vertical, this is equal to 4.8 sine of 30 degrees, and if we solve this one, this is equal to 2.4 newtons up to 2 SF. And this question has only 1 mark, and this one should be the answer mark. Part 2 says, by taking moments about the hinge, determine the weight W of the beam. So simply we have to take moment about this point. So this is over pivot point. So simply you can imagine this one is the pivot point. This is over pivot point. And in the question it is given to us the force by the spring in upward direction is equal to 8.2 newtons. So the moment due to this force, this will be counterclockwise. So we can say this will be CW, CCW counterclockwise, and moment due to weight, this one will be clockwise, and moment due to this force, this also will be clockwise. And tension has two components. One component is acting vertically downwards, and the magnitude of this one is equal to 2.4 newtons, and moment due to this one about this pivot also will be clockwise. That moment due to this component will be equal to 0. So we can say moment is equal to 0 due to horizontal component, because this is passing through the pivot, so moment is equal to 0. Now simply we need to write down counterclockwise moments has to be equal to clockwise moment, and counterclockwise moment we have 8.2 times the distance from the pivot, that is equal to 0.5, and this one has to be equal to the moment due to this weight W times distance we have 0.60 plus moment due to this one, force is 0.30, and the distance is 0.80 plus due to vertical component, that is 2.4, means vertical component is equal to 2.4 newtons, and the distance from the pivot, so here we have 8 plus 0.4 means 1.2, so this is 1.2. Now if we solve this one for W, we will get value of W is equal to 1.6 newtons. So the final value of weight is 1.6 newtons up to 2 SF. So this is how you need to answer this part of the question. For our third part, we need to calculate the horizontal component of the force exerted on the beam by the hinge. Mean horizontal component of the force exerted by the hinge on the beam. So we need to understand, as this beam is in equilibrium, so the resultant force in any direction has to be equal to 0. So if you look at forces acting along horizontal, means sum of the forces along horizontal, it has to be equal to 0. And in this case we have one force that is acting to the right, and this is the tension in the spring, so we have this is TH, and TH in this case will be equal to 4.8 cosine of 30 degrees. As this beam is in equilibrium, so force by the hinge on the beam, it has to be to the left. So it has to be to the left, force by the hinge. And force by the hinge has to be equal to the horizontal component of the tension in the string. So simply we can say force due to hinge, this one has to be equal to horizontal component of the tension, and horizontal component is equal to 4.8 cosine of 30 degrees. And now just we need to solve, and if we solve this one, our final answer will be equal to 4.2 newtons. So this is the horizontal force exerted by the hinge on the beam. So this is just conceptual question. So forces in all directions, sum of the forces has to be equal to 0, otherwise beam will accelerate, beam will not be in equilibrium. So this is how you can calculate, and this question has only 1 mark, and this one should be the answer mark. Part B says the spring obeys Hooke's law and has an elastic potential energy of 0.32 joules. Calculate the compression of the spring. For this question, it is given to us the force applied by the spring on the beam is 8.2 newtons. So the force applied by the beam on the spring also has to be 8.2 newtons, and these two forces have to be in the opposite directions because these are action and reaction forces. And for this question we need to calculate EPE. We need to calculate compression, but EPE is given, and elastic potential energy of the spring in this case will be equal to the work done by the force on the spring, and this one will be equal to 1/2 Fx. So we have value of EPE. In this case, value of EPE we have. So simply we can plug in that value, and we have value of force, and we can calculate value of x. EPE is given to us, that is 0.32, and here we have 1/2, and force is given, that is equal to 8.2, and we can calculate value of x. And if we solve this one for x will be equal to 0.078 meters up to 2 SF, because the raw data in this question we have up to 2 SF. So the final answer also should be equal to 2 SF. So this is how we can answer this part of the question. Part C says the string is cut so that the spring extends upwards. This causes the beam to rotate and launch the block into the air. The block reaches its maximum height and then falls back to the ground. Figure 2.2 shows part of the path of the block in the air shortly before it hits the horizontal ground. The block is at a height of 0.090 meter above the ground when it passes through point A. Means when it is passing through point A, its height is given to us. The block has a kinetic energy of 0.044 joules when it hits the ground at point B. Mean at this point the kinetic energy of the block is given to us, that is equal to 0.044 joules. Air resistance is negligible. Calculate the decrease in gravitational potential energy of the block for its movement from A to B. Means when block move from A to B, what is decrease in gravitational potential energy? So this question is pretty straightforward one. So we need to calculate decrease in GPE. So simply we can say delta GPE in this case will be equal to mg delta h. And for this question, weight of the block we have, that is equal to 0.30. So this is the block, weight of the block we have. So simply we can write on this is 0.30, and the decrease in height, that is equal to 0.090. Now if we simply multiply, we will get 0.027 joules. So this is decrease in GPE of the block between A and B. So our final answer is 0.027. And this question has 2 marks. The first mark will be if you have written this formula, you will get 1 C mark, and if you have got the right answer, you will get 2 marks. Part 2 says use your answer in C1 and conservation of energy to determine the speed of the block at point A. It simply means that we need to find the speed of the block at this point. So simply we need to calculate value of V. And for the block the weight of the block is given, so we can calculate mass of the block. So we can say mass of the block will be equal to the weight of the block divided by 9.81. So this is mass of the block. Now for this question, we have already calculated change in GP from A to B. So we can write down here change in GPE. This one will be equal to GPE at point A. If this is our reference line, mean here if we take GPE is equal to 0. If GPE here equal to 0, we can say change in GPE is equal to GPE at point A, and that is equal to 0.027 joules. So this is value of GPE at this point. We also have value of kinetic energy at point B, means when it just gonna hit the ground, at that point we have kinetic energy, that is equal to 0.044 joules. So it simply means that this is the total energy of the block, because in this case, for this question, it is given to us that A resistance is negligible. So simply we can say the total energy at point A, this is equal to the GPE at point A plus kinetic energy at point A. So we need to calculate kinetic energy at point A first of all. So this one will be equal to the total energy at point A, and total energy at point A is equal to 0.44, because in this case mechanical energy is conserved, minus GPE at point A. GP is equal to 0.027. So if we solve this one, we will get 0.017 joules. So this is the kinetic energy. Now we need to calculate speed. So kinetic energy will be equal to 1/2 mv square, and this is equal to 0.017. From here we can write on V will be equal to 2 times 0.017 divided by m and root of this one. Now simply we need to plug in value of m. So we have 2 times 0.017 divided by mass, that is equal to 0.30 divided by 9.81. Now if we solve, we can get value of V, and value of V in this case will be equal to 1.1 meters per second up to 2 SF, because the raw data in this question we have up to 2 SF. So this is the answer for this question, and if you have written these steps, you will get 3 marks. Third part says, by reference to the force on the block, explain why the horizontal component of the velocity of the block remains constant as it moves from A to B. So for this purpose, we need to understand, if we take the velocity of the block at point A, velocity is pointing in this direction, and this velocity has 2 components. One component is vertically downwards and one component is to the right. And now if you look at the forces acting on this one, there is only one force acting on this block, and that force is force of gravity. So due to force of gravity, the vertical component of the velocity will go on increasing, and as there is no force along horizontal, so the horizontal component of velocity will remain constant. So simply we can say, in this case, resultant force is vertical, or simply you can say gravity is acting vertically downwards. So we can say resultant force in this case is force of gravity is vertically downwards. So simply we can say resultant force is vertically downwards. That's the reason horizontal component will remain constant, because there is no force along horizontal. And this question has only 1 mark. If you have written this point, you will get 1 B mark. I mean, this one has to be in your answer. Part 4 says the block passes through point A at time TA and arrives at point B at time TB. On figure 2.3, sketch a graph to show the variation of the magnitude of the vertical component Vy of the velocity of the block with time t from t is equal to TA to t is equal to TB. Numerical values of Vy are not required. So we have already discussed, as the block is moving in this direction, this is the velocity, and the force acting on the block is only in vertical direction. So this is vertical component of velocity, and here we have, this is the horizontal component of velocity, and the force is acting only in vertical direction, and this is the single force acting on the block. So it simply means that Vy will increase with constant acceleration. As the resultant force is constant, so acceleration is also constant. So acceleration is also constant. And here we have V against t graph. So it means the gradient of Vt has to be constant. Gradient of Vt, this is equal to A, and this one has to be constant. So simply we have to draw a line with positive gradient. So if we take downward is positive, if we take down is positive, so it means acceleration is positive, so the gradient has to be positive. So simply we need to sketch a line with positive gradient. So we can assume it has certain value of velocity, vertical component of velocity at A, and then velocity keep on increasing. So this is how we can draw the line. So this should not be from the origin, because at point A, block has certain velocity of vertical component. So this is how you need to sketch. Question 3 says a block is pulled in a straight line along a rough horizontal surface by a varying force capital X, as shown in figure 3.1. A resistance is negligible. Assume the frictional force exerted on the block by the surface is constant and has magnitude 2.0 newtons. The variation with time t of the momentum of the block is shown in figure 3.2. So we have momentum against time graph. Part A says state Newton's second law of motion, and Newton's second law of motion, simply we can state F is equal to delta P over delta T, and F here is the net force. So simply we can say resultant force on any object is proportional to rate of change of momentum, or simply you can say is equal to rate of change of momentum. So this is how you need to define Newton's second law of motion for AS physics. So let me show you how you can write down your answer. So this is how you can write down your answer. So these things you have to mention. You need to say resultant force on an object is proportional to, or you can say is equal to, the rate of change of momentum. Means F net is equal to delta P over delta T. So this is the true form of Newton's second law of motion. Part B says use figure 3.2 to determine for the block at time t is equal to 2.0 seconds the magnitude of the resultant force on the block. Mean only at this time t is equal to 2.0 seconds. So we have here momentum on y-axis and we have t on x-axis. So if you look at the gradient of this one, gradient will be equal to delta P over delta T, and delta P over delta T, this is equal to net force, mean this is equal to the resultant force. So simply we need to calculate the gradient. So we can take any point on this line, any 2 points, and we can find the gradient, because gradient is constant, so resultant force is constant from 0 to 4 seconds. So we can take this point. So here we have value of momentum, that is equal to 6.0, minus we have 0 because at this point we have 0.0, and we can divide this one by 4.0 because time is 4 minus 0.0. Simply 0 you can write. So we will get this is equal to 1.5 newtons. So this is value of resultant force. And for the second part, we need to determine the force X, means this force. This force is the applied force. So we need to understand Fx, we can say the force X minus friction. Minus friction, this is equal to F net, mean this is equal to the resultant force. But for this question, we need to calculate force X. So I'm writing just X here. So this will be equal to F net plus frictional force. I'll be writing small f. F net we have calculated, that is equal to 1.5, and frictional force is given in the question, that was equal to 2.0. So it means this is equal to 3.5 newtons. So the value of force X is equal to 3.5 newtons. And this question has only 1 mark. If you got the right answer, you will get 1 mark. Part C says, on figure 3.3 sketch a graph to show the variation of force X with time t from t is equal to 0 to t is equal to 6.0 seconds. We have already discussed until this point the value of the net force F net, this is equal to 1.5, and the value of Fx between 0 and 4, that is equal to 3.5 newtons, because 1.5 plus 2, and in this case means between 4 and 6 seconds F net is equal to 0. So the value of X has to be equal to friction, and value of friction is equal to 2.0 newtons. So simply we have to divide this one into 2 parts, 0 to 4 seconds and 4 to 6 seconds. So simply we can write down 0 to 4 seconds. In this interval of time, value of Fx, this is equal to 3.5 newtons, and from 4 to 6 seconds Fx is equal to 2.0 newtons. That's all. So now we need to sketch the graph. So simply we can sketch between 0 to 4 seconds. The value of X is 3.5, so this is 3.5 newtons, so we can draw the horizontal line, and between 4 and 6 seconds value of X is 2 newtons. So this is how you can sketch the graph. Let me show you the clear one. So this is how you can sketch. And that's all for this lesson. Means we have discussed almost half of this paper, and remaining half I'll be uploading by tomorrow. And if this video was helpful, please like and subscribe, and also leave some comments in comment section. And if you have any questions, also leave in the comments section, and I will try to answer as soon as possible. See you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023 paper 2 variant 1. In the last video, we have discussed first half of this paper, and in this video, we will try to cover the remaining half of this paper. Means we will talk about waves, we will talk about electricity, we will talk about radioactivity. Let's study together, let's improve together. Question 4 says, a beaker in air contains a liquid. The base of the beaker is in contact with the liquid and has area capital A as shown in figure 4.1. The liquid has density rho and fills the beaker to a depth h. By using the definitions of pressure and density, show that P is equal to rho gh. P is the pressure due to the liquid that is exerted on the base of the beaker, and g is the acceleration of free fall. So in order to answer this question, a pretty straightforward question for AS student, the best way to answer this question is we can start with the P is the pressure, and P is equal to force over contact area, F over A. And force in this case means force on this area. This force is due to the weight of the liquid. So simply we can say this is equal to weight of the liquid, W divided by A. And W is equal to M times G. So this is M times G divided by A. And M is equal to density of the liquid times volume of the liquid, and volume of the liquid simply we can express in terms of A and H. Means the cross-sectional area of this beaker, if we multiply with height, that is equal to the volume of this beaker. So this is the volume times G, and this is divided by A. So simply you can cancel A with A, so we left with rho GH. So this is what we need to prove for this question. Part B says, suggest why the equation in A does not give the total pressure on the base of the beaker. We have already calculated that P is equal to rho GH. But this is not equal to the total pressure on the base of the beaker. So we have to explain why it's not. So we can simply write down here. So this is P total. P total has to be equal to rho GH plus something is missing, and that one is the air, because on the top of this beaker there are air particles, means there is atmosphere. So you can simply imagine there is atmosphere on the top of that atmosphere, and atmosphere is exerting also pressure at the surface. So the total pressure at the base of the beaker, this is equal to rho GH, means due to liquid. So this is the pressure due to liquid. So we can say this is P liquid plus P air, or you can say P atmosphere. So this is how you can calculate P total. So simply we can say, because there is air pressure, or you can say there is atmospheric pressure. You can say air, or you can say there is atmospheric pressure. So this is how you can answer. This question has only 1 mark, and that one has to be the B mark. Part C says, figure 4.2 shows the variation of the total pressure inside the liquid with depth x below the surface. Determine the density of the liquid. So in this case we have pressure on y-axis and we have depth on x-axis. So simply if you look at the gradient of this one, gradient of the graph, gradient will be equal to delta P over delta H, delta P over delta H. And now if we compare delta P, we can write down change in pressure. This will be equal to rho G delta H. From here we can write down delta P over delta H. This one will be equal to rho times G. So simply in this case we can say rho, this one will be equal to delta P over delta H, and this will be divided by G. So we have G here. So simply we can say we need to calculate the gradient and we need to divide gradient by G. So in order to calculate gradient, we can take 1 point here, we can take 1 point here. You can take any 2 points, but it's better to take these 2 points because it is more convenient to calculate. So here we have value of P, that is equal to 9.66. And we have value of P here, that is equal to 9.60, and this is multiplied by 10 to 4, and this is divided by delta H, means from here to here, and this is in centimeters, so we have to be careful with units. So this is 8 minus 0 multiplied by 10 to minus 2 multiplied by value of G, that is equal to 9.81. Now if we just simplify, we will get our answer, that is equal to 764.5 kgs per cubic meter. Up to 3SF we can write down this is equal to 765 kgs per cubic meter. So this is the final answer, and this is how you can calculate. So it simply means that in this case rho is equal to gradient divided by G. So when you have any question about the graph, so first of all look at the gradient of the graph, and second look at the area under the line, so you can get informations to calculate any quantity they ask you to calculate in the question. In this case we have to consider the gradient, then rho is equal to gradient divided by G. So this is part D says a solid cylinder is held stationary by a wire so that the base of the cylinder is level with the surface of the liquid as shown in figure 4.3. The cylinder has length 4.0 times 10 to minus 2 meters and cross-sectional area of the cylinder is 3.7 times 10 to minus 4 meters square. The tension in the wire is 0.53. The cylinder is now lowered and then held stationary by the wire so that the top of the cylinder is level with the surface of the the liquid. Calculate the new tension in the wire. So we have two cases. First of all, we can say case 1. For case 1, if we draw the free body diagram, we have mg of the cylinder that is acting vertically down, and we have in this case tension that is acting vertically up. This is the tension in the wire, and this is equal to 0.53 newtons. So from here simply we can say mg is equal to T because the cylinder is not accelerating. So it is stationary, it means forces on the cylinder are balanced. Simply we can say the weight of the cylinder, this is equal to 0.53 newtons. So this piece of information we can get from case 1. And for the second case we can use a different color. For the second case, it is given to us that top of the cylinder is level with the surface of the liquid. So until here, now we have liquid. So we can draw this line. Until here, we have liquid. So this is the second case, the red one. So we can say this is our second case. For the second case, if we draw the free body diagram, we can draw mg will not change. So mg is still acting vertically downwards, and there is a tension in the cylinder. So we can draw there is some tension in the cylinder. So this one is the tension. So we can say this is T, and also there will be upthrust on this cylinder due to the liquid. So this one is the upthrust. And in the second case, cylinder is still stationary. So it simply means that in this case mg is equal to T plus U, but we need to calculate the new value of T. So this is T new. So we can also write down here T new. So we have to calculate T new. So we can write down here T new. This one will be equal to mg, and this will be equal to mg minus upthrust, and mg is equal to 0.53 newtons minus the upthrust. And upthrust is equal to weight of the fluid displaced. Weight of fluid displaced. So we can say weight of fluid displaced. I'm just writing in detail so you can understand this one, not just simply use direct formula and give you the answer. I want you to feel, I want you to understand. Okay, so now here we have this is 0.53 and weight of the fluid. So it means this is equal to mass of the fluid. So let me write down here weight of the fluid. This will be equal to mass of the fluid times G, and mass of the fluid will be equal to density of the fluid times volume of the fluid displaced times G. And for this cylinder we have cross-sectional area of the cylinder and we have its height. So we can say this will be equal to rho F times, because this is the volume of the fluid displaced, equal to the volume of the cylinder. So this is, so we can write down this is A times L times G. Now simply we need to plug in numbers. So we have here this is rho F times A, cross-sectional area of cylinder, times height of the cylinder times value of G. Now simply we need to plug in numbers. So we can write down T new. This is equal to 0.53 minus, we have density we have already calculated in the previous part, that was equal to 764.5, and value of A is given to us here, and this is 3.7. so this is 3.7 times 10 to minus 4, and we have value of L that is given here, and this is equal to 4.0 times 10 to minus 2, and we have value of G that is equal to 9.81. If we solve this one, our answer will be about equal to 0.42 Newton. So this is new value of tension, and this is how you can calculate. Question 5 part A says an electromagnetic wave in a vacuum has a wavelength of 8.4 times 10 to minus 6 meters. State the name of the principal region of the electromagnetic spectrum for the wave. So this is 10 to minus 6, and if you look at the spectrum, 10 to minus 3 to 10 to minus 6 meters wavelength. This is in infrared range. So this is infrared. So this range you need to understand. So this one is infrared, And for the second part, we need to calculate the frequency, and our answer has to be in terahertz of the wave. So we have the wavelength and we need to calculate frequency. Frequency simply will be equal to V divided by lambda, and speed of light, means speed of electromagnetic waves in vacuum, is equal to 3 times 10 to 8 meters per second, and the lambda is given to us, that is equal to 8.4 times 10 to minus 6. And now if we solve this one, we will get 3.6 times 10 to 13 hertz. So this is the frequency, but answer has to be in terahertz. So we can write down 3.6 and times 10 to 1 tera, 1 tera, this is equal to 10 to 12. So this number is important. So this is 10 to 12. So it means that we have 3.6 times 10 to 1 tera. Simply we can say this is equal to 36 terahertz. So the final answer is 36. Part B says an arrangement that uses a double slit to demonstrate the interference of light from laser is shown in figure 5.1. The light from the laser has a wavelength of 6.2 times 10 to minus 7 meters and is incident normally on the slits. The separation of the two slits is A. The slits and the screen are parallel and separated by a distance of 2.8 meters. 2.8 meters. An interference pattern of bright fringes and dark fringes is formed on the screen. The distance on the screen across 8 bright fringes is 22 millimeters, as illustrated in figure 5.2. For part B1, the light waves emerging from the two slits are coherent. State what is meant by coherent. Coherent simply means that the phase difference between two waves remains constant, or simply we can say two waves, they have the constant phase difference with time. So simply we can write down constant phase difference between the waves with time. Means the phase difference between waves does not change with time. If the phase difference between two waves, let's say, is 90 degrees, it remains 90 degrees with time. It does not change with time. If the phase difference is 180 degrees, it remains 180 degrees with time. For the second part, we need to calculate the separation A of the slits, and this experiment is about double slit. So simply we can say in this case A times X, this one has to be equal to lambda times capital D. A we need to calculate, so A will be equal to lambda capital D divided by X, and X is the fringe separation. So this is fringe separation. Very important concept, you need to understand what exactly it's meant by fringe separation. Fringe separation means that distance between two consecutive bright fringes. Distance between two consecutive bright fringes. Bright fringes. Very important point to understand. Bright fringes. If this concept is not clear to you, you can't do this question. For this one, you can see we have, this is representing the bright fringe. So we have one bright fringe here and we have another bright fringe here. So it means this distance, this is value of X. And here you can see we have another, so this is also value of X, and this is also value of X. 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 And this is also value of X. And finally, this is also value of X. Now, if we count this one, how many we have? 1, 2, 3, 4, 5, 6, 7, 8. So it simply means that we have 8X, that is equal to 22, and we need to find out value of X. So this is 22 divided by 8, and this is in millimeters. Now simply we need to plug in values here. Value of lambda you can get from here. It is given to you, that is equal to 6.2 times 10 to minus 7 meters, and value of D is given, that is equal to 2.8 meters divided by X. X is in millimeters, so this is 22 by 8 in millimeters, so we have to convert this one into meters. Now if we simply solve this one, our final answer will be equal to 6.3 times 10 to minus 4 meters. So this is our final answer. Part C says fringe P is the central bright fringe of the interference pattern in B. Fringe Q and fringe R are the nearest dark fringe and the nearest bright fringe respectively to the right of fringe P as shown in figure 5.2 respectively. So it means dark fringe is Q and R is the bright fringe. We need to calculate the difference in distance, or simply we need to calculate the path difference from each slit to the center of fringe Q. So here we have bright fringe here, next one is the dark fringe, then we have the bright fringe. So we need to understand n for the center bright fringe is equal to 0. So this is the fringe order, and n is equal to 1 for the first bright fringe after center bright fringe, n is equal to 1, and for the next bright fringe n is equal to 2. So we need to understand the meaning of that. N0 means that PD is equal to 0, n is equal to 1 means that PD, the path difference, this one is equal to 1 lambda. N is equal to, it means the PD for this bright fringe to be formed has to be equal to 2 lambda. As the dark fringe is between n is equal to 1, n is equal to 0, so the PD for the dark fringe, so we can say PD for dark fringe, this one has to be equal to lambda by 2. We can also write down the journal formula. For bright fringe, we can write down a journal formula for bright fringe. Bright fringe, we can say PD has to be equal to n times lambda. N can be 0, it can be 1, it can be 2, it can be 3, and so on. And for dark fringes, the PD, this can be n plus 1 by 2 times lambda. So when n is equal to 0, so we can say n is equal to 0, so the PD, this one has to be equal to lambda by 2. So lambda by 2. So for the first dark fringe, PD has to be equal to lambda by 2. We can also understand this one wave is coming here, another wave is coming from this slit. So what is the PD between these two waves? PD, this PD has to be equal to lambda by 2. If we draw the normal from here, so the PD between these two waves, so this is PD, and this PD has to be equal to lambda by 2. And so this is the concept you need to understand. So simply we can say PD, we are talking about the dark fringe, first dark fringe, this one has to be equal to lambda by 2. And value of lambda we have, this is given in the question, that is equal to 6.2 times 10 to minus 7, and this is divided by 2. So our final answer will be equal to 3.1 times 10 to minus 7 meters. So this is the PD for the first dark fringe to be formed here. For the second part, we need to state the phase difference between the light waves meeting at the center of fringe capital R. And fringe capital R, we need to understand this fringe is a bright fringe. So this is bright fringe. So this is first bright fringe after center maximum. So we have here, and the fringe order for this one, n is equal to 1. If fringe order is 1, it means the PD, this one has to be equal to 1 lambda, and the phase difference, this one has to be equal to 360 degrees. So the phase difference simply between the waves has to be equal to 360 degrees. So these waves are still in phase. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023, paper 2, variant 1. In the last two videos, we have already discussed from question 1 to question 5. And in today's lesson, we will talk about remaining questions. Means we will talk about question 6 and question 7. Question 6 is about electricity and question 7 is about radioactivity. We will discuss these questions in detail as always we do, so you can improve your conceptual understanding of AS physics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 6 says a metal wire in a circuit has a length of 1.8 meters and a cross-sectional area of 1.5 times 10 to minus 6 meters square. The total number of free electrons in the wire is 2.3 times 10 to 23. There is a current in the wire so that a charge of 172 coulombs moves past a fixed point in the wire in a time of 2.5 minutes. For part A, we need to show that the number density of free electrons in the wire is 8.5 times 10 to 28 per cubic meter. Number density. So first of all, let's try to understand what is number density. Number density is simply equal to number of free electrons per unit volume. So you need to be very clear about this one, number density. We denote number density with letter small n. Number density is equal to number of free electrons per unit volume. Number of free electrons are, you can say, charge carriers. Free electrons are, you can say, charge carriers per unit volume. So this is how we define number density. Simply we can say number of free electrons per total volume, total number of free electrons per total volume. So in this case we have total number of free electrons, that is equal to 2.3 times 10 to 23. So we have this number of free electrons. We need to divide by volume of the wire. Length of the wire is given to us. The wire we are treating as a cylinder, so this is a cylindrical wire. So this is cylindrical wire. In this much volume we have these number of free electrons. Cross-sectional area of this one is A and the length of this wire is L. So we need to find out its number density, means the number of free electrons per unit volume. So we need to divide total number of free electrons by total volume of the wire. And volume of the wire will be equal to A times L, and L is given, that is equal to 1.8 meters, and cross-sectional area is 1.5 times 10 to minus 6. Now if we solve this one, we will get 8.5 times 10 to 28 per cubic meter. So this is the number density. And this question has only 1 mark. If you have got the right answer, you will get 1 A mark. Part B says calculate the average drift speed of the free electrons. In order to calculate average drift speed of the free electrons, simply we have to use transport equation. Means I is equal to NQVA. And V is the drift speed here. So we need to calculate V, so we can make V the subject. So V is equal to I divided by NQ times A. But in the question, I is not given to us. I is equal to Q divided by T. T is the time, and this is divided by NQA. Value of Q is given to us in the question. Now simply we need to plug in those values. 172 coulombs, and the time taken was given, that was equal to 2.5 minutes. So we have to convert this one into seconds. So this is 2.5 multiplied by 60, means we have to convert into seconds. And value of N we have just calculated, that was equal to 8.5 times 10 to 28. And Q is the charge on single charge carrier, means on single electron. So we can say this is 1.6 times 10 to minus 19 coulombs. And the value of A is also given in the question, and that is equal to 1.5 times 10 to minus 6 meters square. Now simply we need to solve this one. If we calculate, our final answer should be equal to 5.6 times 10 to minus 5 meters per second up to 2 SF, because the least number of SF in the raw data we have, that is equal to 2 SF. So our final answer also should have 2 SF. So this is our final answer. Question 7 says a battery of electromotive force 9.6 volts and negligible internal resistance is connected in series with two fixed resistors and a thermistor as shown in figure 7.1. The fixed resistors have resistance of 3400 ohms and 5800 ohms. The reading on the voltmeter is 6.0 volts. Calculate the current in the resistor of resistance 5800 ohms. So simply we need to calculate current passing through this resistor. So we can say we have to calculate value of this current. We can say this is I1. In order to calculate value of I1 simply we can connect a voltmeter in this way. So we have one voltmeter that is connected here. So let's say this is V and this is connected between these 2 points. Another voltmeter we can connect across this resistor. Let's say this one is V2. So this is our second voltmeter and this one is our first voltmeter. So in this case 9.6 volts mean EMF of the battery, this one has to be equal to V1 plus it has to be equal to V2. V1 in this case is given to us, that is equal to 6 volts, mean reading on this one and reading on this voltmeter, they are the same because they are connected between two same points. This is 6.0 volts, so we can say this is 6. We have to find value of I1, so V2 will be equal to I1 times resistance of this resistor, that is equal to 5800. Now simply we have to solve this one for I1. So I1 in this case we can write down, this one will be equal to 9.6 minus 6 divided by 5800. If we solve this one, we will get our final answer 6.2 times 10 to minus 4 ohms. So this is amount of current passing through this resistor and amount of current coming from this battery, that is also equal to I1, and this is equal to 6.2 times 10 to minus 4. We need to understand current entering the battery and leaving the battery has to be the same. For part B, we need to calculate the resistance of thermistor. Imagine that resistance of this resistor is equal to capital R. And in the previous question means in part A, we have already calculated amount of current coming from the battery, means I1 we have calculated. And the value of I1 was equal to 6.2 times 10 to minus 4 amps. And if you look at this junction, at this point there will be no current passing through this voltmeter because the resistance of ideal voltmeter is equal to infinity. So resistance of this voltmeter is infinite. So it simply means that current passing through this resistor and thermistor is the same. So it means they are connected in series. And if you look at this junction, there will be no current passing through this voltmeter because its resistance is infinite. So it also means that current passing through this resistor is also equal to I1. So it simply means that these three resistors, they are connected in series with this battery. So we can write down 9.6 EMF. This one has to be equal to total current in the circuit times the total resistance. So we have 3400 plus we have R plus we have 5800, and value of I1 we have, that is equal to 6.2 times 10 to minus 4, and here we have 3400 plus we have 5800 plus we have capital R. Now simply we need to calculate this one for R. If we solve, our answer should be 6.3 times 10 to 3 ohms. So this is resistance of thermistor. Pretty straightforward question. Don't get confused with this one. that some current is passing through this. No current is passing through this one because resistance of ideal voltmeter is infinite. Part C says the initial energy stored in the battery is 2.6 times 10 to 4 joules. Assume that EMF of the battery is constant. Determine the final energy stored in the battery after a charge of 330 coulomb has moved through the battery. In order to answer this question, simply we need to understand the meaning of EMF. So we can write down here EMF. EMF is the amount of chemical energy converted into electrical energy per unit charge. It simply means that the amount of electrical energy supplied to each coulomb charge. Or we can say that EMF is equal to energy supplied per unit charge. So this is the main concept you need to answer this question, per unit charge. So we can also say if EMF is equal to 9.6 volts, what does it mean? It simply means that 9.6 joules of energy will be given by the battery to 1 coulomb charge. So this is meaning of 9.6 volts EMF. But for this question, we need to calculate final energy when this much charge passes through the battery. If 1 coulomb charge pass, battery will lose this much energy. If this much charge pass through the battery, how much energy battery will lose? That one we can simply calculate delta E lost. Delta E lost. So that one simply will be equal to 9.6 means EMF 9.6 joules divided by 1 coulomb. So this is the EMF, and we need to multiply with amount of charge, total amount of charge passing through the battery. So coulomb will be cancelled, so we can calculate amount of energy lost. That one will be equal to 3170 joules. But for this question we need to calculate final stored energy. So we can say delta E means the energy loss. This one will be equal to the initial energy minus final energy. Final energy is lower. That's the reason we are writing EI minus EF. Now simply we need to plug in values. So I'll be writing here delta E. So we can say delta E, this is equal to E initial minus E final. So this is delta lost. So E final from here will be equal to E initial minus energy loss, means delta E. So we have initial amount of energy that was stored in the battery, that is equal to 2.6 times 10 to 4. 2.6 times 10 to 4. And the energy lost we have 3170. So the remaining amount of energy we will have, that is equal to 2.3 times 10 to 4 joules. So this much energy is remaining in the battery after this amount of charge has passed through the battery. So this is meaning of EMF. So final answer is 2.3 times 10 to 4 joules. This is how you need to answer. Then this question has 2 marks. You will get 1 mark if you have calculated this energy. You will get 1 mark. That one will be C mark, and the final mark you will get if you have got this right answer. Part D says the environmental conditions change causing an increase in the resistance of the thermistor. State whether there is a decrease, increase or no change to the temperature of the thermistor. For this question it is given to us that resistance of the thermistor increases, so temperature has to decrease. And if resistance of thermistor decrease, it means temperature will increase. If you look at the curve for thermistor, resistance against temperature curve, let's say we have temperature on x-axis, the shape of the curve is like this. So it means when temperature is lower, resistance is higher, and when temperature is higher, resistance is lower. So simply in this case we need to write down temperature of the thermistor decrease. Current in the thermistor. Now we need to understand if resistance increase, mean this resistance increase. So how about the total resistance of the circuit? R total has to increase. Total resistance of the circuit increase. So it means that I total has to decrease because all these components, they are means these three resistors, thermistor and two resistors, they are connected in series, so current will decrease. So current in the thermistor decrease, so this one will decrease. Potential difference across thermistor, this point is little bit tricky one. For this purpose we can simply write down EMF, this one has to be equal to I times we have 3400 resistance plus we have I times R plus we have I times 5800 ohms. EMF is constant, current in this case decreases, but this one is constant, so it means overall here this V will decrease. And if we look at this one, resistance increases. First of all, let's look at this one. This resistance is constant, this current decreases. It means PD across this one also will decrease. We can say this is V1, we can say this is V2. So the PD across thermistor, it has to increase because EMF is constant. So in this case current decrease but resistance of thermistor increase. So overall, if I say this is V3, overall V3 has to increase. So we can simply say this one increases. So this is how you need to answer. Nice question about DC circuit. Question 8 says an isolated stationary nucleus X decays by emitting an alpha particle to form a nucleus Y. Nucleus Y and nucleus Z are isotopes of the same element. For part A, by comparing the number of protons in each nucleus, state and explain whether the charge of nucleus Y is less than, greater than, or the same as the charge of nucleus Z. If you look at the question, it is given to us that Y and Z, they are isotopes of the same element. Isotopes of any element, they have the same charge. So simply we can say they have same charge. Now we need to state why do they have the same charge? Because they have same number of protons in the nucleus. So they have same number of protons in the nucleus. So this is how we can answer this question. For the second part, we need to compare nucleus Y with nucleus X. But for this question, it is given to us nucleus X decays by emitting an alpha particle to form nucleus Y. It simply means that nucleus X forms nucleus Y by emitting alpha particle. We can also assume atomic number of X, Z and mass number of this one is A. So the atomic number of Y has to be Z minus 2 and its mass number has to be A minus 4. Now we need to understand what is meaning of minus 2. Minus 2 means that Y has 2 protons fewer than nucleus X. So it has 2 less protons. So we can say 2 protons less than X. 2 protons less than X. So it simply means that Y has less charge. So we can simply say less charge on Y. Less charge on Y. Now we need to explain why less charge on Y. Because Y has 2 fewer protons than X. Protons than X. So that's the reason Y has less amount of charge. Part B says use the principle of conservation of momentum to explain why nucleus Y cannot be stationary immediately after the decay of nucleus X. A typical type of question, you will see this question in many past papers. So try to master how to approach this type of problems. In order to answer this question, imagine that we have nucleus X and this nucleus is at rest initially, so the initial momentum of this one is equal to 0, and this nucleus X becomes nucleus Y by emitting alpha particle. So we have here nucleus Y and here we have alpha particle. So this is alpha particle. Alpha particle is emitted from the nucleus X. It means alpha particle must have some speed. So we can say it has certain speed. Let's say its speed is V alpha. So in this case, now you need to understand for the momentum to be 0, for the final momentum has to be equal to 0. So if we use conservation of momentum, final momentum also has to be equal to 0, and final momentum can only be 0 if these two particles, they have equal and opposite momentum. We can also imagine that, let's say this particle moves to the left. We can say its speed is Vy and its mass is My, and mass of alpha particle is M alpha. So we can simply write down here, we have to take one direction as positive. So in this case, we are taking to the right is positive. So we have momentum of alpha particle, and this momentum has to be negative. So here we have My and here we have Vy. From here, if we solve this one for Vy, we will get Vy is equal to M alpha times V alpha divided by My. As Vy is positive, it means that our assumption is correct. So Y has to move to the left. So these are the points you need to understand to answer this question. Very basic question and also a typical type of question. Let me show you how you can write down your answer. In your final answer, you have to mention these points. You can say total momentum before decay is 0. So total momentum after decay must be 0 as well. So Y must have equal and opposite momentum to alpha particle, because in this isolated system we have only two particles after decay. So the momentum has to be equal and opposite. So Y cannot be stationary. And that's all for today's video. We have done whole paper. I hope this paper was helpful. If this paper was helpful, please like and subscribe, because your encouragement is very important. And I'll be uploading paper 2 variant 2 from May June 2023 very soon. See you in next video.